Hello friends, this is Mr. Professor Abhijit Anand Ayode, lecturer as Praveen Patil College of Diploma Engineering and Technology, Bhayandar. Today in this video we are going to study about the fifth chapter of the subject IME, Industrial Measurement. The subject code is 22420. The fifth chapter is Temperature Measurement. This chapter covers almost 12 marks. Okay. In this chapter, we are going to study about temperature and its unit, temperature scale and conversion, classification of temperature measuring transducers, just like a field system thermometer, vapor pressure thermometer, expansion thermometer, bimetallic thermometer, electrical methods, just like a thermistor, RTD, thermocouples. Okay. After that, we are going to study about the Seebeck effect, Peltier effect, okay, pyrometers. In this video all these things will be covered. So let's start. Now the first topic is temperature and its unit. Temperature is the most fundamental parameter and it is measured and controlled industrial variable. It is required to be measured in various sectors: domestic, commercial, industrial, testing methods, investigation, all these things. Various industrial products are mostly temperature dependent. So accurate temperature measurement is very important, and the temperature measurement instrument and the method must be given due to the importance. Now the definition of the temperature. It is a thermal state of the body or a mass substance which determines whether it will give heat or it receive heat from other bodies. Heat and temperature are closely related. Temperature may be defined as degree of heat, but heat is usually taken as a quantity of heat. There is no heat flow between two bodies if two are at the same temperature. Temperature cannot be measured directly but must be measured by observing the effect that temperature variation causes the measuring devices. Substance to give heat or to take heat from surrounding depends on thermal state of the substance. Well, there is some different temperature scales. First one is the Fahrenheit temperature scale, degree Fahrenheit. At standard atmosphere pressure of 14.7 Pascal, the freezing point of distilled water is designed at 32 Farad and the boiling point is at 212 Farad. It is a very important things. हो सकता है कि आपके मल्टीपल चॉइस क्वेश्चन के लिए भी एक क्वेश्चन आ जाए. The freezing point of the distilled water is designed as a 32 Farad and boiling point of the water is 212 Farad. For this scale, 459.7 Farad is the absolute zero temperature. It is one of the important thing. Between this span of ice, that is the freezing point, and the boiling point, this scale is divided into the equal 180 fundamental divisions. The scale is linear scale, degrees Fahrenheit, that is used in the medical and in engineering branches. Now the second one is the Celsius temperature scale, degrees Celsius. In this case, the melting point of the distilled water ice taken equal to 0, that is a 0 degree Celsius. The boiling point at 100 degrees Celsius, absolute 0, for this scale is 273.15 degrees Celsius. Between these two stages of 0 degree Celsius and 100 degrees Celsius, the scale is divided into 100 equal parts or the divisions. This scale is also linear scale and used in a scientific and engineering field. Also it is used in the medical branches. Interconversion of Faradays and Celsius is Faradays is equal to 9/5 degrees Celsius plus 32. Why 32? Because 32 it is freezing point. Or degree Celsius is equal to 5/92 Farad minus 32. Now the Kelvin temperature scale. In such scale, melting point of the ice is taken 273.15 degree Kelvin and the boiling point as 373.15 degree Kelvin and the absolute zero scale is 0 degree Kelvin. This is called as a absolute scale. This span is equally divided into 100 fundamental division. Okay. This scale is also used in a scientific and medical and engineering works. Interconversion degree Kelvin is equal to degree Celsius plus 273.15. आपको मल्टीपल चॉइस क्वेश्चन के लिए आ सकता है, हो सकता है कि आपको इस पे कोई क्वेश्चन में जस्ट लाइक कन्वर्ट 30 डिग्री टेम्परेचर इनटू द केल्विन फ़ारेनहाइट यूनिट, तो कैसे करना है ये भी हम इस सब्जेक्ट में देखने वाले हैं. ओके, नाउ द क्लासिफिकेशन ऑफ टेम्परेचर मेजरिंग ट्रांसड्यूसर. Actually, the classification of temperature measuring transducers are divided into three groups. First is a field system thermometer, another one is a expansion thermometer, and third one is a electrically temperature instruments. Now, field system thermometer are divided into three parts. First one is a liquid field thermometer, another one is a gas field thermometer, and third one is a vapor field thermometer. But in case of the expansion thermometers, it is divided into three parts. It is a bimetallic thermometer, primeta-hexis thermometer, spiral bimetallic thermometer. And in case of the electrically temperature instrument, it is divided into three parts: thermistor, RTD, and thermocouple. Out of the above different types of the temperature measuring devices or the transducer, as per our syllabus, only some types will be studied. जैसे the first type is फील्ड सिस्टम थर्मोमीटर का फर्स्ट टाइप है वेपर प्रेशर थर्मोमीटर. वह हमें स्टडी करना है. ये जो अभी आपको यहाँ पे डायग्राम दिखाई दे रही है, इस डायग्राम में आपको अलग अलग पार्ट्स भी दिखाई देंगे. सो इसके मेन पार्ट्स कौन थे? सबसे मेन पार्ट्स है यहाँ में हर एक पॉइंट का नंबरिंग दिए है. तो फर्स्ट नंबर पे आता है बॉर्डन ट्यूब. सेकेंड वन इज द फ्री एंड ऑफ द बॉर्डन ट्यूब, जो यहाँ पे आपको दिखाई देगा. नाउ द थर्ड वन इज अ होलाटाइल फ्लूइड, यहाँ पे है होलाटाइल फ्लूइड. ओके, फोर्थ इज नॉन होलाटाइल फ्लूइड, और उसके नीचे आपको दिखाई दे रहा है नॉन होलाटाइल फ्लूइड. फिफ्थ वन इज अ वेपर, जो ये जो है यहाँ पे वेपर हमें दिखाई दे रहा है. मतलब सबसे नीचे है नॉन होलाटाइल फ्लूइड, उसके बाद होलाटाइल फ्लूइड, और उसके बाद वेपर. ठीक है, फ्री सरफेस, जो नॉर्मल जो दिखाई दे रहा है ये जो है वो फ्री सरफेस है. उसके बाद कैपिलरी ट्यूब, जो हमें यहाँ पे कैपिलरी ट्यूब दिखाई दे रही है. उसके बाद आता है मेजरिंग स्केल. वो तो मेजरिंग स्केल हमें यहाँ पे क्लियरली दिखाई दे रहा है, ये मेजरिंग स्केल यूनिफॉर्म मेजरिंग स्केल है. उसके बाद इंडिकेटर, यहाँ पे एक इंडिकेटर है जो स्केल इंडिकेट करेगा. उसके बाद फिक्स बट पाइवोटेड एंड ऑफ फॉर इंडिकेटर, जो यहाँ पे आपको दिखाई देगा, फिक्स बट पाइवोटेड एंड ऑफ द इंडिकेटर. लास्ट वन इज 11th इज द बल्ब, जो यहाँ पे आपको दिखाई दे रहा है कि यहाँ पे एक बल्ब है. चलो ना इसको एक्सप्लेन करता हूँ मैं थोड़ा ब्रीफली. कंस्ट्रक्शन जो हमने देखा वो है वेपर प्रेशर थर्मोमीटर का कंस्ट्रक्शन. बल्ब कंटेन अ नॉन वोलेटाइल फ्लूइड एट द बॉटम. One, it is a volatile fluid, free space, and in the upper side there is a vapor. Capillary tube very long, about 5 meters. When a thermometer functions, the liquid in the vapor pressure thermometer boils. Vapor is produced as a vapor inside the capillary tube and also in the Bourdon tube. How the vapor condenses? When the temperature of the surrounding substance drop, the liquid and the vapor inside the bulb also cool. So some of the vapor condenses inside the pressure decreases. This produces the motion of the Bourdon tube and free moves. The indicator and the free end of the Bourdon tube is attached by the string. Hence, indicator moves on the scale indicating the temperature, and the scale is calibrated to read the temperature directly. Now there is some advantages, disadvantages and application of the vapor pressure thermometer. The first advantages is it requires no electricity. इलेक्ट्रिसिटी की यहाँ पे कुछ भी ज़रूरत नहीं है. गुड एंड सेटिस्फैक्ट्री टाइम रिस्पॉन्स. सेंसिटिविटी इज टू मच बेटर. एक्यूरेसी इज अप्रॉक्सीमेटली प्लस माइनस 1%. मतलब इतनी ज़्यादा एक्यूरेसी है, इसी 1% ही टॉलरेंस है. ऑपरेशन इज स्टेबल, कॉम्पैक्ट एंड स्टडी कंस्ट्रक्शन. कॉस्ट इज नॉट मच. Temperature indicated in the scale are also facilitated to take a record of the temperature for a duration of the time by providing recording mechanism. These are the advantages of the vapor pressure thermometer. Now what is the disadvantages? First disadvantage is span of the temperature is limited. Another one is can't be repaired. Replace is the most solution. Okay. In comparison with an electrical thermometer, it has a less accuracy, sensitivity and a less span of the scale. Application, it used in the clinical purpose. Wide range temperature measurement के लिए भी इसका यूज हो सकता है. So the remaining point, that is the expansion thermometer, will be studied in the next video. Thank you so much.